How's it going? This is Mr. Hernandez, and I am here to introduce you to solving radical expressions. In your notes, in your notebook, definitely want to put today's date. For you, it's definitely not the 10th. It'll be the 11th or the 12th. But yeah, just put the day's date and then the title. You could pause it anytime. But I want to break down this word first. So what is a radical? So a radical is really a square root. Okay, so anytime you see something like this is the radical. This is the radical symbol. And so why do we call it the radical? Well, it's because sometimes you could put another number right here, a little tiny number that would go on the top left. I'm not going to even say what it's called, but we usually use radical and square root synonymously, like interchangeably, the same exact thing. But square root is just this special radical, and I'm not going to get into it that much. But in order to make it an equation, you just got to put equals some number, right? Like equals whatever, 3. And so that automatically makes it an equation when you put an equal sign and some other number. All right. So that is the first step, is knowing what is a radical. And of course, this comes right after we were doing the activity where we were, the dropped objects activity. And we looked at the graph. We looked at the graph of the radical, and we saw that it was the pretty much, the same as, if you look, you don't have to write this down, but this is just another kind of way of seeing it. So the graph of a radical function looks like this, and the graph of a quadratic function looks like this. And so what I had you notice was, this is actually the radical, which is the square root of x, is actually half of a quadratic function, which is x squared. So if you compare the two, they are related. They have the same shape, and they're actually called inverse functions, but we'll get into that in a little bit. So in order to solve for a variable like x, we need to get x by itself. So here's the equal sign. Okay, so what is the way of x being by itself? Well, this square roots, or the radical. How do you get rid of a radical? What's the opposite of a radical? Is it addition, subtraction, multiplication, division, something else? Well, the opposite of addition is subtraction. Opposite of multiplication is division. And so here we are actually at an x. This is like the same level as an exponent, this square root. This actually is, so a square root and a square are pretty much on the same level of being classified as exponents. There's a way to actually write this radical as an exponent. It's a rational exponent, but I'm not going to get into that yet. But just know that these are related, and they actually undo each other. Just like if you had multiplication and division, addition and subtraction, they undo each other. So whenever you see a square root, you could basically square both sides, which is the rule, right? Whatever you do to one side, you do to the other. And so whenever you have a square and square root, you're basically going to cross them both out. So make sure you cross them both out. This x drops down now without anything, and now we just have the 9 squared, which is 81. So you've solved the radical function. Okay, so this number 2 is a little bit trickier. We're going to stick with PEMDAS. PEMDAS tells us that we need to, basically to solve, we go from the bottom up, okay, to solve, when solving. When you're doing, when you're just combining like terms, you start at the top down, but when you're solving, you're undoing what was done to it, and you're going in the reverse order. So I'm going to basically, this is subtraction, this is the exponent or a square root. So this is subtraction, which is at the very bottom. So that's what we're going to get rid of first. And this here is pretty much on the same level as the exponent. and that's what we're going to get rid of last. Okay, so the opposite of subtraction is addition. So we are going to add the 2 to get to the other side. All right, that's going to, let's see, we're going to bring down the square root of x equals, and then 1 plus 2 is 3. And then now we're left with this square root, and we're going to do the same thing we did above. We're going to square both sides. The square and square root undo each other, and we're left with the x now by itself. And 3 squared is 9. Okay, so what if you have something in front of it? Well, we're still going to follow PEMDAS. Oops. And what we have here, instead of addition or subtraction, we have this 2 that's basically, so this square root is here and with the exponent. This 2 actually, between the 2 and the square root, there's like a multiplication going on. So you could put a dot. Anytime the number's making contact with the square root, that's basically multiplication. So if we're going to follow PEMDAS, and we're going to do it in reverse order, we're going to get rid of, in this case, multiplication and then division. So here's the multiplication, so we're going to divide both sides by 2. That's going to turn into 1, and that's just the square root of x. Okay, 12 divided by 2 is 6. And then we have our familiar, squaring and square rooting. So if you see a square root, you square it. That's going to cancel out. They're inverses of each other. And 6 squared is 36. So inverses basically undo each other. So if you're looking at the inverse of multiplication, what we had, the inverse of it is division, and that's what canceled the 2's out. And over here, the square root, the inverse is a square. So whenever you see a square and square root, they undo each other, just like a multiplication and division. Okay, last one. This combines pretty much all of them together, but we are going to stick with PEMDAS. We are going to first identify what is happening with this x. So this x has a square root. That's what we're going to have. Multiplication and addition. Okay, so in this case, we're actually going to have to start from the bottom and then go up to the square root. So we're going to get rid of addition by subtracting. So we're going to subtract 1 to both sides. And then we're going to be left with 3 square root of x, or 3 times square root of x equals 15. And of course I made these problems up, so I made sure that they gave you nice numbers. So opposite of multiplication is division. So we're going to divide both sides by 3. So that's a nice number. And then now we have a nice square. So we already did the inverse of multiplication to get division. The inverse of a square root is a square. So we're going to do that to undo each other. They're gonna basically cancel out. We say cancel out, but they're inverses of each other. So we're left with x equals, and then 5 squared is 25. All right, well, I hope that helped you out. Have a good one.